Not so long ago, I had the actual news visiting me here in the workshop, and this happened.
Frangen bestilte en litt uvanlig pakke fra Kina, tok det helt av på nett. Nå blir videoene hans sett av millioner.
Du tar med ladninga. Ikke ta med det. Jeg vil gjerne ha filmen, men du må ikke legge ut på TV2.
So I was just going to demonstrate how my homemade radio-controlled CyberPlow worked, but first I had to disconnect the charger. The machine is powered by these two car batteries. They are 12 volt, but connected in series for 24 volts. But as you can see, it's a little tight in there. So when I tried to disconnect the charger, something like this happened. Ah, shit. So this charging situation is not exactly ideal. And this got me thinking, what if I can charge the CyberPlow the same way as I do with my Ford Lightning? I mean, it's way easier if I can charge it the same way as I do with this Ford. Yeah, right. So this was probably a bad example. It's a diesel. I just made it Lightning. But yeah. So my point is that I think it will be a lot easier to charge the CyberPlow with a EV charger. And when it comes to EV charger, I think the easiest one to install is the Easee. So there it is. So now the most easy part is finished, but I don't have any place to connect the cable. So yeah, let's start doing the more difficult part.
So, how are we actually going to make this EV charger, which is basically just a smart control contactor, charge the 24 volts battery inside the CyberPlow? Well, first we need a Type 2 charging socket, so we have somewhere to plug in the actual cable. And that part is easy, it's just to drill a hole and mount the socket. And like this, we have somewhere to connect the charging cable. And to actually do the charging, we need a 230 to 24 volt charger to connect to the batteries, And just like that, we are done. Except for we are not done, not at all, because a Type 2 EV charger is not just a fancy wall socket with an electrical switch or contactor inside. The EV charger is designed to communicate with the car before it allows power to flow, and there is a long list of conditions that must be met before it does a handshake and starts charging. So inside the charging cable there is therefore a signal wire called CP, short for control pilot. Before charging can start, the wall charger must detect the car through the control pilot, and it must also confirm the car's status, whether the car is ready for charging, how much current it can draw, and a bunch of other things. It makes sure a long list of safety conditions are met before charging starts. And this is all to prevent overheating, fire, damage to the batteries, and other dangerous situations. When all the criteria are okay, the charger will close the internal relay or contactor, and power will run from the EV charger to the onboard charger in the car. So now, the big question. How do we bypass all these safety functions?
Yeah, let's start making this thing.
In this video I need to add this one. To turn a smart and safe charging process dumb and dangerous, I'm using whatever I have laying around. An Arduino Uno, resistors, transistors, relay, a display, and a few other questionable components.
So to store all the electronics, I have designed some kind of enclosure in Fusion 360. And I'm gonna 3D print all these parts on my Bambu Lab 3D printers, both the X2S and also the brand new X2C.
Yep, you guessed it. This video is sponsored by Bambu Lab. Ever since the X1 Carbon was released, I've been hooked on 3D printing, and today I have 5 printers. in my workshop, the cabin and office. So when Bambu Lab offered to send me their flagship H2C, I didn't need much convincing. Built on the H2D platform, the H2C features the vortex system, allowing it to automatically switch between multiple hot ends, colors and materials with less waste, and of course much higher print speed. It also offers the large build volume of 330 by 330 by 325 millimeters, making it ideal for larger projects and batch printing. Since receiving it, it has been in almost daily use, and almost every print has been a great success. So if you're looking for a new 3D printer, I can highly recommend the H2C. Check out the affiliate link in the description. And now, back to it.
So I must admit that this came out quite perfect. So this is the charger, can be placed like so, and then I have some airflow here, and also for the fan there and on this side. And to lock it in place, I made a little slot so that I can just insert this little guy like so. Yeah. So it will be like so. Now it doesn't move. And now I can fit the Arduino. And of course the threads are perfectly aligned, so the board should fit exactly in there.
This board comes without mounting holes, so I simply drill them aligned to the threads.
There it is.
I hooked it up to these car jumper wires to test it out, and to my surprise it seems to work. But of course it needs some more programming and calibration.
So let's start mounting the socket. So I'm thinking it will be both practical and quite cool to have it on the side here. So I cut out this simple template. Ah shit, I need to move it a little bit.
It's that feeling that makes you wanna.
Yeah.
It's that feeling that makes you wanna.
Yeah, that's absolutely perfect. So to cover all the wires coming out on the back side here, this is 230 volt. I'm not going to use this rubber thing. Instead I have designed an enclosure in Fusion 360, and it's in the 3D printer right now. So while I wait for the enclosure to get finished printing, I'm going to start making the bracket to hold all the electronics. And it's going to be placed somewhere like this, I think. So let's figure it out. Of course, it's on the underside. $59. And since it's quite difficult to drill into the frame here, I'm gonna weld some pieces on the sides so that I can just screw them from the sides. Yeah. Where is the glasses? Where are they? Safety goggles. Let's use this one.
All I hear, go get the money, so I go get it. Hate means I do something right, so I'ma let 'em.
like this.
All I hear, go get the money. So I go get it. Hate means I do something right. So I'ma let him. Yeah, I'ma let him. Yeah, I'ma let him.
So let's see if it's actually possible to get it in here now. Maybe like... Yeah. So now I can simply drill a hole into this and bolt it on.
And I didn't see this one coming.
So this came out quite nice. Why not to... I just don't like that this one is... And then it's this little guy. And then it's time for the socket, just like so. And here is the 3D printed cover. I just hope it's enough space for it. And I just added a hole in the bottom here for draining, if there is any water getting in there. There is a seal here, so it shouldn't be an issue. I can already see that there is not... or is it? There is enough space. Haha. Exactly enough space. Yeah, there is a little crack there. So before connecting all the wires that also goes through this enclosure, I'm gonna redo it.
Luckily that's quite fast with the H2C.
A lot more beefier and also 100% infill. So this is the old one and new one. That's a lot better.
And then it was the final step before testing. And this only took about 8 hours or something. I also printed the front part for covering the display. To make the display waterproof, I cut out some plexiglass with the X-Tool P3. But in fact, the Bambu Lab H2C can also do this. I have the 40-watt laser kit laying around, and I'm gonna upgrade it in a future video. But this machine is also a beast. I mean the X-Tool P3.
So now it's just for me to wait for the print to reach the correct print layer, and then I'm gonna insert the glass between, like a sandwich. So now the printer has stopped as planned, and I can insert the little glass. And hopefully the printer will just print on top of the glass, making it a watertight sandwich. It didn't work exactly as I wanted, but maybe. I guess I should have cleaned the glass with some alcohol or something. So I'm gonna give the glass a good clean of some alcohol, and then we can start the print from the same layer. So now it should be a lot cleaner. And I don't know, but maybe it's best if the glass is laying on top of the heat bed for a while and get some heat to it. Maybe a warmer glass will make it stick a little bit better.
Yeah, that seemed to have made all the difference. Before mounting the display, I'm soldering on all the wires. I also made a lid for the electronics box. The same workflow with the sandwiched glass. And then it's time to cut the hole for the display and buttons.
Yes, I'm thinking something like this. So let's mount the display. So I made this back piece to make the display somewhat waterproof. Maybe. At least it's something to fasten it to. So the wires goes through this little hole. I hope. Should have made the hole a little bit bigger, I think. Yeah, that works. So let's hope all the holes for the threads fits. That's perfect. Then we can insert the threads. Very nice. So my plan is that this part will be on the inside of the hole I have cut out. And of course, this part with the sandwiched plexiglass will be on the outside. This gap is the same thickness as the steel in the CyberPlow. And when I tighten the screws here, it will close itself off. Just like so. And then the outer part will go on like so.
To help me make the 1000-line code, I used ChatGPT.
Aha. Perfect. Finally, it's time to test this thing. So finally, after Yeah. Fixing up my driveway, the battery is somewhat low. But that's not a problem now. So now you see it's charging 7.6 amps and 0.02 amp hours and counting. Through this display I have made some kind of a menu so that if I push this button I can toggle between different information. And if I go to the next page I have this timer. It has been charging for 20 seconds and in about 8 hours it will automatically shut off in case I forget it or something like that. And if I go to the next page, that's the best function, I think. And the next one, yeah, the CyberPlow by Frengen Engineering text running. And if I go to the next one, I have this manual stop. So if I hold for 3 seconds, it stops. And now I get this summary, 0.14 amp hours and 1 minute and 6 seconds. And I can also manually start it again. So 3, 2, 1, release, start. Control pilot and start in 1 second. Now it's charging. And since this is a smart charger, I can also control everything from the app. So in the app I can now see 0.2 kilowatts and if I press it, 2.3 amps and 238 volts. And I can also manually stop the charging. So if I stop it, of course, it stops. 7.6 amps, and now it will stop. Yeah, 0.2. I think it's because of the condensator in the charger. And after about 30 seconds, if the amps is below 0.5 amps, the charger will cut off. I mean the relay in the control box here. Yeah, now. And of course I have the same charger inside the workshop also.
And at last, a little bonus.
A great feature with both of these printers, both the H2S and H2C, is that they both have dual nozzles. And this way it can print with 2 different filaments, one in each nozzle, without the filament needing to go back into the AMS and down again. But to use the dual nozzle setup, I'm dependent on having an external spool into the external inlet behind here.
You can also have several AMS units working together, but I'm not doing that.
And this setup, yeah, it's not ideal. But the great thing about the Bambu Lab community is that there is so many users of the Bambu Lab printers. And with all their users, they have made something called the Maker World, where you can upload your files to the world. So if you think of something clever that you want to print, there is a big chance that someone has already been clever before you. And then you can simply search for it in the search bar and hopefully find exactly what you are looking for. For instance, this wall-mounted spool holder for the external spool. So instead of having this kind of shitty solution for the external spool, I simply downloaded the file that someone else has made and printed this. So I think this bracket was intended to just be screwed onto the wall with, yeah. But since I have the metal shells on top of the 3D printers, I want to add magnets so that I can simply stick it on and take it off. And the mounting holes is way too oversized. So I'm gonna use these little guys. It's a M3 thread and it's made for squashing it and yeah, you know, this thing, like so. And then I'm gonna add the magnets. And for the roller, I add these 2 bearings, like so. Simply, this is going to be a problem, I guess. But I think it should be fine if it's always pulling this way. So let's see. Nice. I don't think it's... So I think I'm gonna add some hot glue on the inside here to fasten the bearings, but still. Nice. This will work. Perfect.
Thanks to you for watching and to Bambu Lab for sponsoring this video. Have a nice day. Bye.